some bits of the homework you're not too sure about? Yeah, of course. That's what I'm here for. If you just get them out of your rucksack, we can go through them together. Yeah, it's not a problem. Right. Okay. Are these the only two? Absolutely fine. So, 2-digit addition. Was this the formatting you weren't aware of, or was it just getting a bit much for you? No, that's fine. So, this is a way we use format addition to make it more logical in our minds. Okay, so we've got the two numbers and the subject of the maths, so negative, positive, times and division, multiplication or division, and these are all pluses, so they're just straightforward adding it to number. So 58 plus 2, 60. Okay, 60. You mind if I have some lunch or do this? No, thank you, mate. So we'll move on. So in the same breath, 51 plus 8 is 59. Right? Okay. Good stuff. And yeah, we'll do some more of these. So 14 plus 1, 15. Yeah, of course. Well done. Now we're getting to some slightly more bigger numbers. So you've got 56 plus 7. Now, how would you visualize doing that mental addition? Would you visualize 56 and then count 7? How would you do it? Okay. Interesting. Yeah. No, if that's the way that works for you, of course. So you're more welcome to annotate all over the homework, as long as you can show you're giving your best. That's all that we look for. Okay. So the way that I teach this kind of addition is, you can do it however works for you, but I would do 56 plus the 4 of the 7 gets you to 60, and then you've got 3 left of that 7, so you get 63. Okay, some people do 56 plus 6 is, obviously you've got 6 plus 6, which is 12, so you get 62, and you've got the 1 left over, and you get 63 that way. There's a multitude of ways of doing that kind of mental addition. Here's another one. You've got 89 plus 8. We're really close to that 10 mark. So if you take 1 away from the 8 and give it to the 89, you can get 90, and then you've got 7 left. So it's 97. That's how I would look at it. Try and get yourself to a 10, and then whatever's left, just add that in. As I say, write as much as you need to. That's absolutely fine. The more workings out you show, the better. Okay, 101. Okay. If I hand this to you, can you do some of it yourself? Yeah? I'll help you if you need it. Okay. That's fine. You got better ones. Here you go. 46 plus 1. Brilliant. Well done. Now you've got 54 plus 8. How are you going to tackle that? Okay. Yep. That's the correct answer. So, if that's the best way for you, fantastic. Stick with that. Whatever makes logical sense in your brain. Maths is always logic based. If you can get the right answer, the path you take doesn't matter to anyone else. Okay. It's whatever works for you. So great job. 48 plus 3. Sweet. Well done. Yep. 45. Fantastic. Okay. So you seem to be getting the hang of it, yeah? Brilliant news. I'm glad to hear that. Do you think you could finish the rest of that over lunchtime? And maybe, if it's not all done, you know, I'm sure I can give you some time in class before we start. I understand. That's fine. Good to know. Cool. Missing numbers. Okay. This one was on the harder side. We've got all different orders of operation here. So we've got what plus, what minus, what times, what divides. So we're looking for missing numbers, yeah. So what goes in to 96 to get 302? So you've got all this paper here. So I would start by doing the inverse of what the sum is asking you. So you're looking for the difference between 302 and 96. So effectively, you just need to unbalance the equation and do 302 minus 96, right? Because that will give you the difference, and then obviously those two added together makes 302. So that's how I do it. It can be complicated, I understand. For this paper, I did allow calculators. It was more understanding how, inverting different mental arithmetic problems, it comes about. So it's if you need to understand that kind of thing. So if we do 302 minus 96, we get my calculator out. 302 minus 96, we get 206. So our difference is 206, and all we need to do then is plug that in. 206. So we go 206 plus 96 equals 302. So we know that's correct. So 17.8 plus what equals 64. Exactly the same style of problem. So how do we do that? You want to take the calculator? Yeah? Yeah. Fantastic. That's exactly how we do it. So sometimes you get this, sometimes you get a little fraction. All you've got to do, press that, and it converts it into the decimal. So 46.2 is what we get. 64 minus 17.8. We get 46.2. And all we need to do then is do 17.8 plus 46.2. And we get that 64. Fantastic. So now we're getting into the subtraction. I understand. Be a little scary, and we've kind of got to understand. We've got to do a slightly different scenario here. So we've got what minus 317 equals 508. We've got what minus 317 equals 508. So what you basically do is 508 plus 317, 825, because you're looking for the really big number that you take that 317 from to leave you with 508, okay? So 825. I know it looks, it can kind of mess with your brain a bit. I understand that. You're looking at a small number equaling a big number, and you're like, oh, what's going on there? So I do understand. And now you've got different, you know, now you've got decimals involved. So we've got 67.3 minus what equals 48.2. So you're looking now, you can't add here, because you've got to find a smaller number to get to 48. So in this scenario, I'd use tricks this one. What I'd actually do, minus what equals that? Minus 20. How do I get to 20? I have to tackle it very much stage by stage. So 67.3 minus a number gives you 48.5. So what we do here is we do 67.3, not to the minus, we do 67.3 minus 48.5. Now that gives us 18.8. Okay, now that is actually the number we're looking for, 18.8, because that is the difference within that equation. Right, within that equation, you got those two pieces of information, right? And once you've got those, you can rejiggle around an equation. You've not went to kind of quadratic formulas yet, that's a few years ahead of you. But in those, you're always looking to balance an equation on both sides. And that's kind of what we're learning the basics of here. So 18.8, so we do 67.3 minus 18.8, and that gives us 48.5. You see how I'm doing that? Okay, do you want to give this one a go? So you've got what? Times 31 equals 236. Okay, so you'll do division. Yeah. So you've got. So you've got here. What times 31 equals 1736? Now that's a massive number, right? And it's intimidating. I completely understand that. But what can we do to invert that equation to give us the answer? What is the invert of multiplication? Excuse me. What's the invert of multiplication? Division. Fantastic. So what can we do here to give us that number, do you think? Not quite. Close. Not quite. So you've got the two numbers you need. Okay. You've got both of them. What you're going to do is divide both sides by 31. Right, and you cancel out one side and it gives you the answer. So we do 1736 divided by 31. 56, okay? And we know that because this divides into this 56 times, but those two multiplied together gives us this big number here, because multiplication and division are the inverse of one another. I do I understand if this is a lot. It's early in the year. I get it. But, you know, order of operations is going to be a very big part of exams in the future. So just knowing those basic inverses and understanding how to balance equations, which this is very much the foundation of, really, really help you later. So, 56. What we'll do 56 times 31, 1736. Hang on, love it. Okay, 17. So, 56. You are okay to do all those later. Fantastic. So are you okay to finish these? You've got about 20 minutes of lunch break left. Yeah? Crack on, mate. Crack on. No, it's always great to come see me if you're ever unsure. Yeah? Okay, yeah, I didn't set any homework on that, but I'm sure we can run through it quickly. So, percentages. They can be quite confusing, and in like a shop or something, they always put out a sign that tells you what it is, so you never have to work it out. And it can be confusing, because in the exam they'll word it as like, what is 30% off a number? So you have to work out 30% of it, but then subtract it, if that makes sense. So we'll go for a quick equation here. So if I say, what's 35% of 100? We'll go real simple. What would that be? $35, correct. Fantastic. Do you know how we get there? So, a percentage is per cent. So per 100. Like a century is 100 years, right? So you do, how many per 100 is this? So 1 out of 100 or per 100 is 1%. So that means you take away those two decimals and you're left with 1, right? All we're doing is moving that decimal. So, and there's breakdowns, so 50, 25, 75. Those are halves, quarters, fractions that you can be, what's half of 150? So 50% of 100 is 50, it's half. Those ones are quite simple to work out. But if it was, if an exam question was say, John wants to buy a jumper and it costs £35. The store has a 15% off sale. How much will John pay? So, how would you tackle this question? Would you aim for the percentage off first? Because obviously you've got, it's asking you to do two things, right? So we take the 35, okay, yeah, and we then work out that 15%. So the way I like to break it down, because you've got 15%, you've got a 10 and a 5, right? You can always break it down into 1%. So you basically divide the whole number by 100 to give you 1%. So if you divide 35 by 100, you get 0.35, because you move it 2 decimal points along. So decimal point is after the 5, and then you put it between it for 10%, and you put it to the front for 1%. So you've got 0.35, and you can times that by 15. if you've got a calculator, that's great, but these are normally non-calculator papers because they're mental sums. So because we're looking for a 15%, if we say 35 and we do a 10% and a 5%, because here you work up 10%, you just half that again, and it gives you the 5%, so it makes it a lot easier to break it down. So 10%, we always do is move that decimal point. So what's it equal? 3.5. Fantastic, dude. Okay. And now obviously we get into, the decimal side of things, when you can get things, but if you relate it to money, decimals make a lot more sense, right? £3.50. What's half £3.50? £1.75. Bang on, mate. That's how I always teach decimals. I know you do them separately, but if you reference it to money, everyone has a real life way of working decimals out that way. You know, that they have something to put it to, so it just makes life so much easier to work out. So what you've got here is you've now got to add those up. So use the top down addition we just learned, and if we take the 5 here, we go and we just write down 5. We've got a 5 and a 7. Okay. Now 5 and a 7. Now what's 5 plus 7? Perfect. So what we do here is I'm doing this upside down, so it's a bit confusing. We put the 2 there and put the 1 here. So the decimal point is here. And you got 3 and a 1. So that would be 4, 5. So you got 5. Ignore the hammer, it's terrible upside down. Got 5.25. So £5.25 is 15% of £35. And now, a lot of people mess up in exams and just put that number down. But the question, always go back and reread the question, is asking for what is the cost to John. So you need to then take that £5.25 and remove it from that original £35. So you go 35 minus £5.25. Right. So to do that, it's just some basic subtraction. What you need to do, take that 5 away, so you've got £30, then you've got that 0.25, 25p away from 30, and you've got 75p left over and £29 left over, right? Because you've taken that 1 away. Yeah, so you've got 29.75. So yeah, so 29.75 is the cost of John. Is that clearer? Perfect. Well, I'll tell you what. For homework, I'll issue a new book on percentages, and you can, if you get stuck, come see me, and we'll probably go through it in class, because I feel like it can mess people up quite easily. Is that everything? You'll be getting out lunch soon, so you best crack on with those, and I'll see you later. Okay. Bye, mate.